we are expecting to have CH3 COO negative plus what? H2O. So in this regard, you can now see that the excess of OH negative was chopped off to give us this acetate ion and water, which are neutral. I told you that the only thing that makes something to be acidic or basic is the presence of what? H plus and what? OH negative. So what this buffer are trying to fight against is if there are excesses of H plus and OH negative, what will happen? If there is excess of H plus, the acetate component, which is this negative ion component of the buffer, will what? Will react with that excess acid. This H plus you have here is the excess acid, and then neutralize it, bringing the pH back to normal. Because the presence of this excess acid will raise the pH, or decrease the pH rather, because when you talk about decrease the pH and make the solution to be what? Acidic. Do you understand the concept? It will decrease the pH and then make the what? The solution to be what? Acidic. Is that okay? Good. So what we are looking at for, we are looking for excesses of H plus, because we know excesses of H plus will make the solution to be acidic, and what? Excesses of OH negative, because we know that excesses of OH negative make the solution to be what? To be basic. Do you grab the concept now? So that is how the buffer solution work. So what we are looking for in the buffer solution is, we said it contains what? The acetic acid and the acetate ion. The acetic acid and the acetate ion. Is that okay? Good. Now that you've understood this, let's look at the basic buffer. Now basic buffer rather, they are buffer that actually buffer solution between the pH. They have pH between 7 and 10. Now they are prepared, acidic buffer, they are prepared from weak acid and their conjugate base. Now for basic buffer, they are prepared from weak base plus their conjugate acid, or the salt of that base. Example is ammonia is a weak base plus ammonium chloride. All right. Now what happens in ammonia and ammonium chloride case? You have ammonium chloride, aqueous. Now when this breaks, it's going to give us the ammonium ion plus chloride ion. Now you have ammonia plus water. This is going to give us ammonium ion plus OH negative. Ammonium ion plus what? OH negative. Because normally ammonium chloride is going to split into two ions when dissolved in water. Salt will always split into the two ions that make it up when they are dissolved in water. You see acetate ion, the acetate ion when it was dissolved in, was it acetate? Yes, acetate ion when it was dissolved, the sodium acetate rather, when it was dissolved in solution, it split into acetic acid and what? Sodium ion. Same thing is what is applicable here. So they will always split into the individual ions that make them up. And then when ammonia dissolved in water, now ammonia cannot split, but rather it can be protonated. Are you getting it now? When it becomes protonated, what happens here is that this one donates a proton to ammonia. Now when it donates a proton to ammonia, ammonia becomes what? Ammonium ion and what? OH negative. So what actually happens in the buffer system? Now listen. In the situation where you have an excess of base, what will this buffer do? Excess of base means excess of what? OH. Are you getting it? Now in the solution where you have excess of OH, you know that listen, you know that if you reverse this reaction, it's going to give us this. So this OH is already part of the system normally. So and this chlorine is already part of the system normally, so you don't pay attention to them. But if there is excess of OH, let's say there are excesses of OH in the solution, what will happen is that this ammonium ion will quickly grab this OH, and when it quickly grab the OH, it will now neutralize it and then bring the pH back to normalcy. So what are you going to have? You are going to have NH4OH. Is that okay? NH4OH. Is that going to be possible? No. Now, it's possible, but we are not going to form NH4OH. What we are going to form is a situation where this ammonium will what protonate OH negative. So when it protonates this, what are you going to form? You are going to form ammonia NH3 plus what? H2O. Do you understand? NH3 plus what? H2O. All right. So at this point now, you've neutralized the excess of what? OH that was present in solution. So you see that what buffers are looking for, they are actively searching for H plus and what? OH negative. That's what they are looking for. Wherever they see H plus, they chop it. Wherever they see OH negative, they chop it off. So let's say there is excess of H plus in the solution. What do you think will happen? The ammonia. Now, you should also know that the weak base will always react with H plus, while the conjugate acid will always react with base, which is OH negative. Why, if you come back here, the weak acid for acidic buffer, the weak acid will always react with OH negative. Look at it. Because say acid buffer consists of weak acid and its conjugate base. Now if you look at this is the weak acid, this is the conjugate base. Are you getting in all this one? Now the weak acid, which is CH3COOH, will always react with OH negative, which is a base. So the weak acid is what reacts with the excess of the base. Worthy of note. Why the conjugate base, in this case now, the conjugate base, which is the source of the acid, the conjugate base is what we react with the excess of what? H plus. You know, excess of H plus is what? Acidic. So of course you expect a base to react with what? Acid. Why acid will react with what? Base. Same thing is applicable here. Now when you come here, told you that the weak acid or the weak base will react with the acid. That is the reason why we see that and the conjugate acid will react with the base. Now if you look at this is the weak base, ammonia. The conjugate acid is what? Ammonium chloride. Ammonium chloride, of course, the chlorine, we don't need it for now. And that's why I had to split to give us NH4 plus ion. Is the ion in solution that we are looking at for. So this ion in solution now is the conjugate acid we're actually looking at for. That conjugate acid now will be the one to react with what? OH negative, because you know OH negative is a what? A base. Do you understand the concept? So what do you think will react with H plus in this case? H plus will be reacted with by a base. And which of the base for in this buffer now? The weak base. And which of them is the weak base? Ammonia. Ammonia is the weak base. So ammonia is going to react with H plus. And when ammonia react with H plus, now the H plus sodium, ammonia is having lone pairs of electron. It will come pick this H plus up via dative bond, which you plant in your year 1, or coordinate covalent bond to form what? NH4 positive. Are you getting it now? So this is going to form NH4 positive. And this is how you actually neutralize certain substances that are acidic in chemistry. All right, exactly. Now let's see one exercise. Say an aqueous solution or aqueous mixture of carbonic acid and sodium hydrogen carbonate can function as a buffer solution. This is the most important buffer in the human body. Write a balanced equation to show how the system works. So it means we have carbonic acid. Carbonic acid is what? HCO, H2CO3. Sodium hydrogen carbonate, something like this. So now a mixture of carbonic acid and sodium hydrogen carbonate will form a buffer. Now what was the first step we say we will take? whenever you are given something like this. Now the first step to take is to write the equation for each of them when they are dissociated in water. This carbonic acid and water. Carbonic acid will act as an acid in water, and water will act as a base. So carbonic acid will donate 1 proton to water. Now when you donate 1 proton to water, what are we expected to form? You will form 1 hydrogen will no longer be here, so you have form HCO3 negative plus this H plus comes here, give us H3O positive. Do you understand? So that is the first case. Now, why sodium hydrogen carbonate? When it dissolves in water, when you pass it through water, it breaks down water molecule. It breaks down this sodium hydrogen carbonate. So you are going to form ACO3. You see that each of they usually form 1 ion. The salt of the acid and the acid, or let's say the acid itself and the salt of the acid usually form 1 ion. Which of them is the weak acid in this case? This sodium, carbonic acid is the weak acid, while the sodium hydrogen carbonate is the salt of the acid or the conjugate base. They will always form 1 ion at this place here. So this gives us HCO3 plus sodium ion will be left here because this whole system here will split. Are you getting it now? Now, what do you think will then happen? If there is excess of H plus and OH negative, there is excess of H plus and OH negative, which of them do you think will react with it? If there are excesses of H plus and OH negative, which of them do you think will react with it? Now listen, like I told you before, that base will always react with acid, while acid will always react with base. If we have excesses of H plus, it means H plus is acidic. It means the base of the buffer is what will react with it. Are you getting it? H plus is acidic, so the base of the buffer is what will react with it. And which of them is the base of the buffer? It's not the conjugate base. Are you getting it now? It is the conjugate base. And the conjugate base now form which ion? This is the ion it formed. So it means that this ion is what will always react with the acid. So you have H plus, and of course you know when this one reacts with this, what will happen is that this group here, both of them will combine together to give us H2CO3, carbonic acid. So how about if there is a little base added to the solution? This is the base here added to the solution. Which component of the buffer will react with that little base added to the solution? Which component of the buffer will react with that base added to the solution? The acid component of the buffer. And which of them is the acid component of the buffer? Of course, it's H2CO3. So you have H2CO3 plus OH negative. Now, what do you think we are going to form here? This group here is going to protonate OH negative. Now, if it protonates OH negative, that means gives a proton to it, we are now going to form, all right? We are going to form, a proton leaves here, negative charge will become visible. You have ACO3 negative plus what? H2O. Is that okay? So that is that. Now, that is how to work with this one. All right, good.